You're listening to the Cyberwire Network, powered by N2K.
Tired of cybersecurity mega conferences? Mwise is different. With a focused agenda and targeted problem solving, Mwise is where security's best go to get better. From September 18th through the 20th in Washington, D.C., you'll join a special community of security's sharpest minds, hear perspectives you might not get anywhere else, and reach a new level of mastery that'll prepare you for what's next. Register early and save at mwise.mandiant.com/conf23. That's mwise.mandiant.com/conf23. Hello, everyone, and welcome to the CyberWire's Research Saturday. I'm Dave Bittner, and this is our weekly conversation with researchers and analysts tracking down the threats and vulnerabilities, solving some of the hard problems, and protecting ourselves in a rapidly evolving cyberspace. Thanks for joining us.
So we were thinking about using generative AI not just for something that can be used to kind of dupe users into executing malicious code, but how the attackers could use it to actually generate or convert some malicious code and some actual exploits to cause some real damage, more specifically in OT and unmanaged devices.
That's Daniel Dos Santos, head of security research at Forescout. The research we're discussing today is titled AI-Assisted Attacks Are Coming to OT and Unmanaged Devices. The time to prepare is now. Well, let's walk through this together. I mean, you have this tool, and I think probably for most of our audience, it's a tool that, at the very least, they've played with. How do you approach this? Where do you begin?
Yeah, so our idea is we took an exploit which we already had that we developed for a kind of a proof of concept that we had in the past for an exploit for operational technology, right, for a programming logic controller. And we wanted to convert that into a different language, right? So the original exploit was written in Python as a short script. We wanted to use that in Go because we see a lot of malware being written in Go these days. And because, it allows for cross-compilation and to run in different architectures and things like that. So we just wanted to explore Go. The issue is that none of us kind of knew Go. So we wanted to explore from the eyes of a complete beginner, let's say, how you would use a generative AI tool to assist in that process. And that actually is interesting because it simulates something that attackers from time to time have to do, which is taking a public exploit, taking a proof of concept, taking a part of a code that actually exists and translating that, converting that, embedding that into other malware, other malicious code to make it more useful, let's say, right? So what we did is we just kind of had a chat with ChatGPT, right, the specific generative AI tool that we used, where we were asking the tool to generate parts of the new code that we wanted it to generate. And in the process, we kind of guided the tool where we needed some corrections or things like that. But the whole process took something like 15 minutes. And in the end, we had the working exploit as we intended.
Well, tell me about the exploit that you were using in your experiment here. What sort of functionality did it have?
Yeah, so originally it was part of a larger attack which we developed where we wanted to show how adversaries can infiltrate networks from the IoT part of the network, so from IoT devices that are exposed like IP cameras and network-attached storage devices and things like that, then move laterally to IT computers, servers, workstations, and then from there move to OT networks and find vulnerable devices like PLCs and then exploit them. And the exploit in this case is a denial of service, right? It's crashing the device so that you need to manually reboot it. Manually in the sense of like power cycling it, like a hard reboot. So what we did is we took this last component part, the part that crashes the PLC, and we wanted to have a very simple version of it, which was avoiding all the network scanning, avoiding all the parts before, and just really focus on the core exploit, which is crashing the PLC by sending a malicious packet. So we kind of just we had the format of the malicious packet, and we told the tool ChatGPT to generate the code around it that would create the connection, send it to the specific target, check if the target is alive, and things like that.
So help me understand here. It was the way you're describing it. So this was not a case of, for example, loading in the Python code and saying, "Hey, ChatGPT, convert this for me."
No, it was not exactly like that, because we wanted to change it a little bit. And also because there are some safeguards in tools like ChatGPT. If it identifies that the code is potentially malicious, or, if you're asking, convert this malware for me or something like that, the tool will actually say, I'm not supposed to generate malicious code or things like that. So we basically just told the tool to take parts of what we wanted, like, write a scanner in Go for this part of the network and things like that. And we were driving the parts of the code that we wanted. Of course, we had a part that was actually, some parts of it were like the equivalent of the Python code that we wanted it to translate, but some other parts were just saying, fix this thing here, or change this part of the code and things like that. So it was not just like put the whole code in and we get the whole code out, right? It was a little bit more of a conversation.
Yeah. You mentioned that ChatGPT has some safeguards built in. How did you approach this to avoid tripping some of those safeguards? Yeah,
so in this case, it was really by not mentioning that things are malicious, right? Because in this case, it was difficult. It would be difficult for the tool to identify that that's an actual exploit. I mean, you're sending a packet over the network, and the packet could be benign, could be malicious, could be just checking if a device is alive. So the payload itself wasn't known to be malicious by the tool. So in this case, you can use it without tripping any of the safeguards, right? Because if you mention specific things like write a malware or create an exploit or let me test this vulnerability or things like that, that would become obvious to the tool that you're trying to create malicious code. But when you're just asking for code, right, code that can have a dual purpose, let's say, the tool won't notice that you're doing anything malicious.
This episode is brought to you by Vonage. Is your business ready to integrate live video chats into your app? The Vonage Video API makes it simple for developers to build custom solutions that make sense for your business. From providing faster tech support and better customer service to hosting more productive meetings and classes, live video enhances every conversation. Go live on your terms with Vonage. Learn more at Vonage.com.
Now, you say that you and your colleagues were, by your own admission, not experts when it came to Go code. How did you evaluate the code that it spat back at you?
Yeah, so that's a good question, because there were two. I mean, the test was actually running it on the network, right? But there are two parts to it. The first is making sure that the code compiles, runs, so the code makes sense. And the second is that the code does what it's supposed to do, right? So the first part is you take the code that the tool spits out and you try to run it. And in some cases, there were issues like missing packages and things like that. And then we just asked the tool itself, ChatGPT, I'm getting this error line. What can you tell me? How can I fix this? And then the tool would realize, oh yeah, I forgot to add one line, or maybe you forgot to add to install this specific package on your computer. So please go ahead and do this, and the following. It was really very kind of step-by-step instruction on how to run the actual code. And the second part to test that it works, it was really when the code was running, compiling, let's say, we could actually just run it on the lab, the same lab where we tested the original Python exploit, and we saw that things were working.
Is there any sense when you look at the code that it generated of how sophisticated or elegant or efficient it is?
Yeah, so in this case, the code was somewhat simple, right? There was nothing too complex around it. There was another experiment we did, which is not published in this research per se, but it was looking at other use cases and applications that were more in the medical domain, like trying to write parsers for some specific protocols to get some data out and things like that. In that case, it was interesting to see, because the code was a little bit more complex, right? It's a parser for some fields in a protocol. It was interesting to see that the tool struggled sometimes with things like regular expressions, but in other cases, it had some very good code in the sense that it follows, standard. In that case, we were using Python, not Go. It follows the standard, Python guidelines for formatting of the code, or for the libraries that you would use and things like that. So it's kind of a mixed bag there, in the sense that you can get very good code, you can get code that works pretty well, or you can get code that is somewhat in between, and works some of the times, doesn't work all the times, right? So you do need, it's not kind of get it and it, for sure it will be running. Sometimes you need to massage the code a little bit, but you can use oftentimes the tool itself to help you do that.
It strikes me that it's potentially a huge time saver, and also takes away that problem of staring at the blank page.
Yeah, I think the time-saving component is the most important one. It's like, again, we could have learned probably enough Go or looked at examples to write it ourselves. But if the tool is there to help you, and it's not just Go, right? Imagine we would want to do the same thing in Rust or in any other programming language, or this thing I mentioned before for the parsers, writing regular expressions can be pretty annoying. If the tool can help you with that, it's a great tool, right? And that's what I mentioned right at the beginning of our conversation, that both the good guys and the bad guys are looking at the tool with the same kind of different motivations, let's say, or different purposes, but the same motivation, right? The motivation is to save time, to gain efficiency, to have more, let's say, return on investment on whatever they're doing. Of course, the purpose in some cases is to detect attacks or to increase business efficiency, or whatever good motivation or purpose that can be. But in other cases, it's to launch more attacks, to have attacks launched faster, to have attacks that might go deeper into a network because you have less time crafting specific exploits for specific environments, or trying to understand the environment you're in, because the tool can help you with that.
So based on what you all have gathered here and learned, what are your recommendations for folks out there who are tasked with defending their organizations? How does this inform that process?
As of now, the attacks themselves, let's say the tactics, techniques, and procedures that the attackers are using, are probably not changing super fast, right? The fact that they are using, or they can be using, generative AI means that the attacks will come faster. They will come probably at a higher rate, a higher volume. So you can expect an increase in attacks, but that's something that we were already expecting, right? We are already experiencing an increase in attacks. This is just, again, probably exploding the number of attacks that we will foresee. So as of now, the nature of attacks is not changing too much. We do expect that maybe in the future there can be new types of attacks, mixing things like disinformation, mixing things like, again, the phishing campaigns that can become more sophisticated, or in some specific domains, like I mentioned healthcare in the past. I really like to cite this research that was not done by us, but it was done by an academic group of researchers a couple of years ago, where they trained a generative adversarial network, again, to create images of patients that had gone through CT scans, and they inserted fake tumors in those images, right? Which is very scary, and it's a terrible use of the technology, but it allows you to imagine what kind of potential outcome attackers can get with that. So I would say for each specific domain, there's probably a different type of attack that in the future can happen that we're not even imagining now. So I would urge, the research community to look at that, people who are domain experts to think about how this technology could be misused in their environment, to look at that. But from a cybersecurity point of view, in general, defending against attacks that we are seeing these days, I would also urge the defensive community, the Security Operations Center analysts, the cyber defenders out there, to look at how to use AI in their day-to-day job to make it more efficient, right? We all know that people are flooded with intrusion detection alerts these days. Maybe generative AI can help you to go through those alerts and see what is actually a threat. We all know that like reverse engineering code and understanding malware code is very difficult. There are people out there looking at how to use generative AI to explain reverse engineered code and make that kind of human understandable, human readable. And so on, right? Even generating code for threat hunting and things like that. So there's lots of opportunities for the defenders as well to use this type of technology for their own purposes.
Our thanks to Daniel Dos Santos from Forescout for joining us. The research is titled AI-Assisted Attacks Are Coming to OT and Unmanaged Devices. The time to prepare is now. We'll have a link in the show notes. Dreamport is a mission accelerator that combines state-of-the-art facilities, innovative programs, and imaginative people charged with finding that spark that leads to unparalleled capability. Headquartered in Columbia, Maryland, Dreamport was created through a partnership intermediary agreement with U.S. Cybercom, awarded to Mwise in May 2018. For more information, please visit dreamport.tech. The CyberWire Research Saturday podcast is a production of N2K Networks, proudly produced in Maryland out of the startup studios of Data Tribe, where they're co-building the next generation of cybersecurity teams and technologies. This episode was produced by Liz Irvin and senior producer Jennifer Iben. Our mixer is Elliot Peltzman, our executive editor is Peter Kilpie, and I'm Dave Bittner. Thanks for listening.